And now in this lecture we find out the radius of a circle. In the drawing we have a circle and the right triangle ABC. This angle equals to 90 degrees in its size, and the side AB equals to 3 units in its length. Line segment AD also equals to 3 units in its length. This is line segment DC, this equals to 1 unit in its length. Point O is the center of this circle, and our task is to find out the radius of this circle. So we define the radius of the circle as R. And we can implement here Rule 25. So I put quickly on Rule 25. According to Rule 25, if from a common external point, that is to say from this common external point, point P, we will draw perpendicular, we will draw tangent PA. Tangent PA is tangent to this small circle at point A, and from the same common external point we will draw line segment PEC that cuts the circle at 2 points, points B and point C. So in this drawing we have tangent PA, and from the same common external point, point B, we have line segment PC that cuts the circle at 2 points, B and C. So in this drawing the following equation is true: that PA square equals to PB times PC. Again, PA square equals to PB times PC. So I can actually implement Rule 25 in our drawing. Now, because in our drawing, this is the common external point, point C. From this common external point, point C, we have tangent CE that is tangent to this circle at point E, and we have also line segment CA that cuts the circle at 2 points, point D and point A. So all the requirements of Rule 25 are satisfied, and therefore we can implement here Rule 25. According to Rule 25, we will get that CE square equals to CD times CA. Again, according to Rule 25, CE square equals to CD times CA. So I write it down. If we focus on the common external point, point C, according to Rule 25, the following equation is true: that CE squared is actually the square of tangent CE equals to CD times CA. So actually, this equation CE square equals to CD times CA is the implementation of Rule 25 in our drawing. If we focus on the common external point, point C, according to Rule 25, CE square equals to CD times CA. CE is the missing side, so we leave it as it is, so it is CE square equals to CD. CD equals to 1 unit in its length, according to what is given in the question, times CA. CA in total equals to 1 plus 3, that is 4. So if you found out that CE square equals to 1 times 4, that is 4, so CE square equals to 4. Here we take a root out of this equation and finally get that CE equals to the square root of 4, that is 2. So the length of tangent CE is 2 units. So write it down. This is tangent CE, that is tangent to this circle point E, and the length of tangent CE is 2 units. In the next step, we will implement the Pythagoras theorem on the big triangle, the big right triangle, triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle ABC, here by PT is the abbreviation for Pythagoras theorem. In the right triangle ABC, according to the Pythagoras theorem, the following equation is true, that AC squared, that is the square of the hypotenuse, equals to AB squared plus BC squared. The hypotenuse AC in total equals to 3 plus 1, that is 4, because AD equals to 3. And therefore, AC squared, the square of the hypotenuse, is 4 squared, that is 16. So AC squared is equals to 16, and it is equals to AB squared. AB is 3, therefore AB squared is 3 squared, that is 9. Plus BC squared. BC is the missing side, so we leave it as it is. So in total, we actually found out that 16 equals to 9 plus BC squared. Here we subtract 9 from this equation, and we get that BC squared equals to 16 minus 9. 16 minus 9 is 7. So BC squared equals to 7. Here we'll take a root out of this equation, and finally we get that BC equals to the square root of 7 units in its length, according to what we found here. So this is side BC, that is equals to square root of 7 units in its length. So BC equals to square root of 7 units in its length. So what is the length of this line segment BE? From the drawing, it is very easy to see that BE in total equals to BC minus EC. So it is known BE equals to BC minus EC. So BE equals to BC equals to 7 units, square root of 7 units in its length, minus EC equals to 2. So in total we found out that BE equals to square root of 7 minus 2 units in its length. So it is known B equals to square root of 7 minus 2 units in its length. BC is tangent to this circle as point E. So we join points O and E together by a straight line. Point O is the center of this circle, point E is the point of the circle itself. Therefore, OE is the radius of this circle, that equals to R according to our definition. OE equals to R. This is the radius of the circle. So, the radius of the circle OE is equals to R. The radius OE is 1 to point E. That is the point of tendency of tangent BC with this circle. And whenever your radius that is 1 to the point of tendency, then tangent BC will be perpendicular to the radius EO. If BC is perpendicular to EO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Angle ABC is the right angle according to what is given in the question. In the next step, we will do a construction, that is to say, from point O, that is the center of this circle, we will draw perpendicular on AB. Again, from point O, we will draw perpendicular on AB. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the construction. We define the touching point of the perpendicular from point O inside the AB, this point is point F. By doing this construction, we can do the quadrilateral OFBE. In quadrilateral OFBE, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 pieces angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this 4 pieces angle must be equal to 90 degrees in its size. So in quadrilateral FOEB we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be this rectangle in front of the square. So we relate to quadrilateral FOEB is a rectangle because it has 4 right angles. Quadrilateral FOEB is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle FOEB, side OE is equal to the opposite side FB, but OE equals to R, it is the radius of the circle, therefore the opposite side FB must be also equal to R units in its length. Likewise, according to the same rule, side BE must be equal to the opposite side FO, but B equals to the square root of 7 minus 2, therefore the opposite side FO must be also equal to square root of 7 units, square root of 7 minus 2 units in its length. FO equals to square root of 7 minus 2 units in its length. In the next step, we will join points A and O together by a straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore AO is the radius of the circle. This equals to R according to our definition. What is the length of side AF? From the drawing it is very easy to see that AF equals to AB minus FB. Again, AF equals to AB minus FB. So AF equals to AB equals to 3 units in its length, minus FB equals to R. So in total we should find out that AF equals to 3 minus R units in its length. This is the answer at AF, that equals to 3 minus R units in its length. In the next step, I'll copy the right triangle AFO in a new page and we'll implement the Pythagoras theorem on this right triangle AFO. Actually, the only variable that is missing in this right triangle AFO is the radius of the circle, that is the radius that we are looking for in this question. So by implementing the Pythagoras theorem in this right triangle AFO, we will find out the value of the radius R of the circle. Side AF of the right line AFO equals to 3 minus R units in its length. The hypotenuse AO is the radius of the circle, that is equals to R. And FO equals to square root of 7 minus 2 units in its length. Here by PT is a abbreviation for Pythagoras theorem. So actually, this is the right triangle AFO that is coming from the original drawing. In this right triangle AFO, according to the Pythagoras theorem, AO squared, that is the square of the hypotenuse, equals to AF squared plus FO squared. So I write it down. AO squared, that is the square of the L'Hopital rule, equals to AF square plus FO square. AO is the radius of the circle, therefore AO it is equals to R, therefore AO square is R square, and it is equals to AF square. AF is 3 minus R, therefore AF square is 3 minus R square plus FO square. FO is square root of 7 minus 2, therefore FO square is square root of 7 minus 2, square root of 7 minus 2 squared. So in total we found out that R square equals to 3 minus R square plus 7 square root of 7 minus 2 squared. So R square equals to 3 minus R squared. 3 minus R squared equals to 3 squared, that is 9, plus R squared minus 2 times 3 times R, that is minus 6R, and we have here square root of 7 minus 2 square. Square root of 7 minus 2 square is equal to 0.417 units. Again, square root of 7 minus 2 square equals to 0.417. So in total we found out that R square equals to 9 plus R square minus 6R plus 0.417. We have R square on both sides of the equation, so R square gets cancelled. So we have in total we found out that actually that 0 equals to 9 minus 6R plus 0.417. Here we relate 6R to this equation, and we get that 6R equals to 9 plus 0.417 is 9.417. So actually in total we found out that 6R equals to 9.417. Here we will divide this equation by 6, and we get that the radius R, that is the radius that we are looking for in this question, is equal to R equals to 1.57 units in its length. And again, the answer to the question is that the radius of this big circle is R equals to 1.57 units in its length. So in the next step, I'll summarize the lecture. Our task in this question was to find out the radius of this circle. So in the drawing we have a circle and a right triangle actually that cuts the circle, and this is angle ABC, that is right angle. Side AB of the right angle ABC equals to 3 units in its length. This is line segment AED, that is also equals to 3 units in its length. This is line segment DC, that is equals to 1 unit in its length. Again, our task is to find out the radius of this circle. So first of all, we define the radius of this circle as R, and we implemented rule 25 in our drawing. If we focus at the common external point C is a common external point in relation to this circle because it is not located inside the circle nor on the circle. Therefore, it is defined, it is located outside this circle, and therefore it is defined as common external point point C. From the common external point C, we have tangent CE that is tangent to this circle at point E, and we have also line segment CA that cuts the circle at 2 points, D and A. Therefore, all the requirements of rule 15 are satisfied, and therefore we can implement all the requirements of rule 25 are satisfied, and therefore we can implement rule 25. Please click on rule 25. According to rule 25, if from a common extent point P, from this common extent point P, we draw perpendicular to, we draw tangent to the circle. This is tangent PA, that is tangent to this circle as point A. In addition, from the same common extent point P, we draw line segment PC that cuts the circle at 2 points, B and C. So actually, we have here tangent PA, and we have line segment PC that cuts the circle at 2 points. Actually, this rule is also defined as a tangent second rule, because PA is a tangent and PC is a secant that cuts the circle at 2 points, B and C. So in this drawing, the following equation is true, that PA square equals to PB times PC. Again, PA square equals to PB times PC. So we can actually implement rule 25 in our drawing. Well, because in our drawing, from the common extent point C, we have tangent CE, we have tangent CE that is tangent to this circle at point E, and we have also secant CA. Secant CA cuts the circle at 2 points, A and D. So all the requirements of rule 25 are satisfied, and therefore we can implement rule 25. According to rule 25, the following equation is true, that CE square equals to CD times CA. Again, CE square equals to CD times CA. CE is the missing side, so we leave it as it is, and it is equals to CD. CD equals to 1, and CA in total equals to AD plus DC. AD is 3, DC is 1, so in total AC equals to 3 plus 1, that is 4. So AC equals to 3 plus 1, that is 4. So in total we found out that CE square equals to CD times CA. CD is 1, and CA, in total, CA equals to 3 plus 1, that is 4. So we found out that CE square equals to CD, that is 1, times CA, that is 4. So in total, CE square equals to 1 times 4, that is 4. CE square equals to 4. Here we took a root out of this equation, and we found out that CE, the length of tangent CE, is equal to 2 units. This is tangent CE, that equals to 2 units in its length. In the next step, we implemented the Pythagoras theorem on this right triangle, triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and it is equals to AB square plus BC square. But again, in the right triangle ABC, according to the Pythagoras theorem, AC square, that is the square of the hypotenuse, equals to AB square plus BC square. It is given us in the question that AC in total equals to 3 plus 1, that is 4. Therefore, AC square is 4 squared, that is 16. And it is equals to AB square. AB is 3, therefore AB square is 3 squared, that is 9, plus BC square. BC is the missing side, so we leave it as it is. So in total, we found out that 16 equals to 9 plus BC square. Here, subtracting 9 from this equation, if we found out the BC square equals to 16 minus 1, that is 7. BC square equals to 7. Here, we took a root out of this equation, if we found out that BC equals to the square root of 7 units in its length. This is side BC. In total, side BC equals to the square root of 7 units in its length. Okay, BC equals to the square root of 7 units in its length. side BC equals to the square root of 7 units in its length. So what is the length of the missing line segment BE? From the drawing it is very easy to see that BE equals to BC minus EC. Again, BE equals to BC minus EC. So B equals to BC, that is square root of 7, minus EC, that is 2. So in total, BE equals to square root of 7 minus 2 units in its length. Again, this line segment BE equals to square root of 7 minus 2 units in its length. In the next step, we join points O and E together by a straight line. Point E is the point of tendency of tangent BC with this circle. And according to Rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. OE is the radius of this circle that is equal to R. The radius OE is drawn to point E, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius EO. If BC is perpendicular to EO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to Rule 1. In the next step, we did the construction, that is to say from point O, that is the center of this circle, we do perpendicular on AB. Again, from point O, we do perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and side AB. This point is point F. By doing this construction, we created quadrilateral OFBE. In quadrilateral OFBE, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 pieces again, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this 4 pieces again must be equal to 90 degrees in its size. So inside quadrilateral OFBE, we have 4 right angles. And according to Rule 5, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral OFBE is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle OFBE, side OE must be equal to the opposite side FB. But OE equals to R, therefore the opposite side FB must be also equal to R. It is the radius of the circle that is equal to R. Likewise, according to the symbol in the rectangle OFBE, side OF must be equal to the opposite side BE. But B equals to the square root of 7 minus 2. Therefore, the opposite side OF must be also equal to the square root of 7 minus 2 units in its length. In the next step, we join points A and O together by a straight line. Point O is the center of the circle. Point A is the point on the circle itself. Therefore, OA is the radius of this circle that is equal to R. What is the length of line segment AF? From the drawing, it is very easy to see that AF in total equals to BA minus FB. BA minus FB equals to AF. Again, AF equals to AB minus FB. AB minus FB equals to AF. So AF equals to AB. AB is 3 minus FB. FB equals to R. So in total, AF equals to 3 minus R. In the next step, I copied the right angle AFO in a new page and implemented the Pythagoras theorem on this right triangle, triangle AFO. This is actually the triangle AFO that is according to the original drawing. In this triangle AFO, according to the Pythagoras theorem, AO squared, that is the square of the hypotenuse, equals to AF squared plus FO squared. AO is R, therefore AO squared is R squared, and it is equals to AF squared. AF is 3 minus R, therefore AF squared is 3 minus R squared, plus FO squared. FO is square root of 2. FO equals to square root of 7 minus 2, therefore FO squared equals to square root of 2. Therefore FO squared equals to square root of 7 minus 2 squared. So in total, we found out that R squared equals to 3 minus R squared, plus square root of 7 minus 2 squared. So R squared equals to 3 minus R squared. 3 minus R squared. We open the brackets here and found out that 3 minus R squared equals to 3 squared, that is 9, plus R squared minus 2 times 3 times R, that is minus 6R, plus square root of 7 minus 2 squared. Square root of 7 minus 2 squared, in total it is equals to 0.417. here we have r squared on both sides of this equation, so r squared will get cancelled. In this equation, in this side of the equation, we left with nothing, that is to say 0. While in the other side of this equation, we have 9 minus 6r plus 0.417. So in total, we found out that 0 equals to 9 minus 6r plus 0.417. Here we added 6r to this equation, and finally found out that 6r equals to 9 plus 0.417. 9 plus 0.417 equals to 9.417. So in total, we found out that 6r equals to 9.417. Here we divided this equation by 6 and finally found out that r, that is the radius that we are looking for this question, the radius of the circle, equals to 1.57 units in its length. Okay, again, we found out that the radius r of this circle is equal to 1.57 units in its length. Okay, thank you very much.